Before I start this video, I'd just like to say we've got two things highlighted at the top of the page. We've got the area of the circle formula, and if you have questions with that, I would go back and watch the other videos about area of a circle. But we have the area of a circle formula at the top, and then we also have our win divided by possible, which is how we figure out these probabilities that we've been going through. So check those things out before we move on to this stuff. For the first one here, we've got area as probability. And the classic problem that you're going to see with these problems is it's going to be most likely a dart hitting a dartboard. That's what you got to think about. If I am throwing a dartboard, and if you're anything like me, if you throw a dart at a dartboard, it's probably going to be pretty random on where that thing's going to land. Unless you practice a lot and you can get really good at pinpointing certain spots, basically you could think about it as putting a blindfold on and throwing a dart in the direction of a dartboard. It's going to hit somewhere randomly on that thing. So that's exactly what we're going to be doing on this problem. We're going to figure out what the probability is that we can hit that little gray circle right in the middle. You can call that the bullseye or whatever. So here is how we set that up. It's going to be the exact same way that we've been setting up the other ones. We're going to be doing win divided by possible, just like we have up at the top right. But in this case, what would be considered a win? Well, if I'm going to win, it's probably going to be hitting in the area of the shaded region. It says in the problem that's what we're trying to find. Find the probability that the dart lands in the shaded circular region. That would be considered a win in this problem. So I'm going to write area of shaded as my win. What is it possible to hit? Well, it's possible to hit anywhere on the dartboard at all. So I'm going to put entire dartboard as my possible on my fraction. So this again is win over possible, W over P. That's the same thing, win over possible. But that's how I'm going to write it out this time, so we can kind of look at that a little bit more in terms of the problem. Another thing I'm going to mention real quick is this is very important to see. 3.14 is what we're using for pi in this problem. So if you were to go on your calculator and you were going to use the pi symbol, your numbers are going to be a little bit off. I'm going to use exactly 3.14 for this problem because that's what the question is asking me to do. And then at the end it says we're going to actually round our answer to the nearest hundredth, so we're going to have a decimal answer for this one. Let's get started. So, area of the shaded region. Area of the shaded region, I'm going to put that as A sub S. So I'm just going to put a little S there to show that that would be shaded. That's just a little note for me to look back to. Now, I know the area of the shaded region. Since the shaded region is a circle, we're going to have to use area of a circle formula. That's why I have it up at the top. So, the area of that little circle there, as you can see, it's kind of tough to tell, but that 5 is actually pointing to the radius of the little circle. So my formula was pi r squared, so I'm going to set it up as pi times my radius was 5, and I'm going to square that 5. Pi r squared. Again, I want to write this out so that you guys can see my thoughts. But when I do this problem, I'm thinking it's 3.14 exactly, because that's what the problem told me to do. 3.14 exactly times 5 squared. And I'm actually going to do that exponent first. If you know your order of operations, that squared has got to come first. So I'm going to do that right away. And I'm going to say 5 squared is 25. If you can type in 3.14 times 25, you're going to get the right answer here. 3.14 times 25, I get to be 78.5. Just like that. Okay. That's only part of the problem, though. We've done the top of our fraction, area of the shaded. We need to do the entire dartboard as well. We need to find the area of the entire dartboard. So area, let's put D for dartboard. The area of the entire dartboard. Well, it's going to be pi times radius squared, but in this case, my radius is 15. That's talking about this line right here. So this will be multiplied by 15 squared. pi times 15 squared. Again, just showing you my thoughts here. 3.14 is what we're supposed to use. We're going to multiply that by 225, which is 15 squared. If you don't believe me, you can check. And if you multiply those two things, you will get 706.5. Okay, so now we've got some actual numbers here. I'm going to change colors here for a second. Let's change again. Let's go with this color. This one here goes with the area of our shaded. And this one goes with the entire dartboard. So we're going to reset up our fraction, except we're going to use these numbers this time. So the area of the shaded we said went on top. So the 78.5 goes on top. And the 706.5 goes on bottom. We're going to divide those things out, and what I get for an answer is 0.1111 repeating. It does say in the question, though, that we need to round to the nearest hundredth, and if you know what the nearest hundredth is, it's two numbers after the decimal place. So if I'm rounding this, this would actually be 0.11. And that would be my final answer, 0.11. Let's talk about what that means for just a second. This is not a percentage. Remember, if you're changing a decimal to a percentage, you have to multiply it by 100. This would basically be saying it's 11%, which if I'm looking at the dartboard itself, 11% of the dartboard being shaded looks reasonable to me. That looks like it's about 11% shaded, so that looks good to me. And that's one thing I always try to check. I try to see if that would make sense in the problem. Let's move on to the next one. So now our dartboard is square with a circle on the inside. It says a dart hits the square dartboard at a random point. Find the probability that the dart lands in the shaded circular region. Again, a win would be inside the shaded region, and we're going to be doing win divided by possible again. So win would be shaded region and possible would be the entire dartboard. And that's how we're going to set up our problem again. So area of the shaded. I'll put A sub S, area of the shaded. That's going to be pi times r squared. Pi times, well, my radius of the shaded spot is, oh, by the way, I'm using the circle formula because the inside is a circle. So the shaded part was a circle, that's why I'm using the circle formula. Pi times radius squared. The way that I think about this is 3.14. It's asking us again to use 3.14 for pi, so that's why I'm doing that. 3.14 times 36. And that's 36 is just coming from me squaring the 6. If I type this into a calculator, I will get 113.04. And I believe that's exact. I don't think I rounded that. So moving on to the next part. We're going to find the area of the entire dartboard. So I used A of D last time. I'll use that again. Area of the entire dartboard. Well, in this case, the entire dartboard is a square. And I know it's a square because it says all sides are the same. Each side of the dartboard is 15 inches. And I guess it also says that it's a square. So it is a square dartboard, which means I'll have to use base times height, which isn't a formula that I put at the top, but base times height would just be 15 times 15. 15 times 15 is 225. Since the base is 15 and this side is also 15, I just multiplied those together. Setting up my final fraction here, area of the shaded region was 113.04. I'm dividing that by my total dartboard area, which was 225. And if I divide those things out, I get 0.5024. But the question says that we need to round to the nearest hundredth. So we're going to do that quick. If I round to the nearest hundredth, it's going to get cut off after the 0 and before the 2. So I will get 0.50. And technically, if you just wanted to write it as 0.5, you could do that as well, because we don't really need the 0. It's not required at the end. So